What this is a way that chemists classify matter. We classify matter based on how it's present either as a pure substance or as a mixture of substances. And when we look at something that we say is a pure substances we say have a definite composition. Definite or fixed composition. While a mixture, on the other hand, over here, mixtures we say have a variable composition. And when chemist uses the word substance actually implies that it's something that is pure. So I need a different color here. We'll put in black. There we go. So the word substance implies pure. So the fact actually that we refer to pure substance, that's a redundant thing. If we simply use the word substance, we could say that matter can be separated into substances and mixtures. And if we say that it's a substance, that implies that it is pure. And substances themselves are broken down into two categories. They are elements and compounds. And so if we look at the elements, where do we find the elements? Where's the example of the elements? Where can we find a list of them?
Periodic table.
Yeah, over here on the periodic table. So if we look at the periodic table, the one on the wall here is showing 112 elements. If you pull out the one that we had in class, and I'm going to ask you to pull it out right now because we'll be using this. There we go. This one here is showing 118 elements. And I've forgotten to update the one here on my handouts to show the symbols of the new elements that we know of today. Looks like this one doesn't have them either. That's all right. Anybody need a copy of the periodic table? And I would see if you never have too many periodic tables. We'll be passing these out all semester long. And you probably have about 10 or 15 by the time the semester's over. Anybody else need one? Okay. Anybody else? All right. So this here is a comprehensive list of the 118 elements we know of today. We have fixed, however, these 3 elements or 4 elements with symbols, and I don't have them off the top of my head. So who has the periodic table from day 1? Element 113 is which symbol?
NH.
NH. And 115 is?
MC.
MC. 117 is?
TS.
TS. And 118 is?
OG.
OG. And I don't even remember what they all come from. But anyhow, these are the ones that we have assigned names and symbols to here. And this is something that's just been done in the last, confirmed in the last like 3-4 months. There was a statement that came out from the International Union of Pure and Applied Chemistry that confirmed these names as something that will now represent our scientific body. But there are no more than 118 elements that are known today. So when you look at this list here, we talk about elements, we know of 118 different elements today. The compounds, on the other hand, these here are combinations of elements in fixed whole number ratios. So an example that this is showing here, this is showing, I believe this is showing sucrose sugar. So if it's showing sucrose sugar, the formula for sucrose sugar is C12H22O11. But another example of a compound would be something like this. This here is salt. Formula, I heard it was NaCl. Exactly. NaCl, which is sodium chloride. And so when we write a formula like this, NaCl, this is telling us we have 1 sodium atom for every 1 chlorine atom. So these compounds then are combinations of elements in these fixed whole number ratios. Then we have mixtures over here. We have homogeneous mixtures and heterogeneous mixtures. These prefixes, homo and hetero, stand for alike and different. And so if we talk about a homogeneous mixture, this means that it is alike all the way through. So if we took a sample out, and I don't have one here with me today, but if we go back to where we were at the end of class last Thursday, when I mixed the sugar and water together and stirred it together, you would have looked at it, and if you looked at sugar water, it would appear as if it was one substance. But it wasn't one substance, it was actually two substances. It was sugar and water. And so we could make different types of sugar solutions simply by dissolving. We could put a pinch of sugar in a big container, or we could put in several spoonfuls of sugar in the same size container, and both of them would be examples of sugar solutions, and that's why we say their composition is variable. But a homogeneous mixture is one that when you look at it, it appears as if it's one, but it's actually a multiple of them. Whereas in a heterogeneous mixture is one that is very obviously comprised of more than one substance. If you take a tossed salad, for example, or garden salad, you look at it, you can very clearly see that there's a mixture of different things that's in there. If it's very obvious, that would be an example of something that is heterogeneous. Which of the following is an example of a pure substance? And if you believe that there's more than one answer, then select more than one. But your choices are white bread, seawater, deionized water, which is the stuff that comes out of here, air and honey, I guess it is. So talk with the neighbor here if you need to. We'll give you about 20 or 30 seconds. And we'll count down. 5, 4, 3, 2, 1. Correct choice here is, and only one, it is deionized water. That's because deionized water is also pure water. Okay? So if we have pure water, what is the formula for water? H2O. Exactly. Water would be an example. H2O. Water is always comprised of 2 hydrogen atoms for every one oxygen atom. So 2 hydrogen atoms to 1 oxygen. Formula is